Pressure in a gas is a little bit different. Now we've gone from one fluid to the other. Water and liquid is both considered to be fluids. They move, they're a fluid. But gas is a compressible fluid, whereas liquid is considered to be an incompressible fluid. We can't change the volume of a liquid very much by pressing on it. Very, very tiny, almost imperceptible amount. But with gas, we can easily change its volume by pushing on it. And so one of the differences between liquid and gas, one of the major differences is that volume and pressure of a gas is related, whereas the volume of a liquid doesn't change. The more pressure we put on a gas, the smaller its volume gets. So if we have some sort of, this is a piston here pushing down on the gas, and it's increasing the pressure by lowering the volume. So we say these two things are inversely proportional. Remember, once again, when one goes up, the other goes down. When we decrease the volume by pushing down with that piston into the gas, lowering the volume of the gas, we increase the pressure of that gas. And so as the volume lowers, the pressure goes up. That's the relationship between the gas's volume and the gas's pressure. So the next relationship is temperature and pressure. So the pressure of a gas is not only related to its volume, but it's also related to its temperature. Because now remember, gases are all these little molecules running around all over the place and knocking into the walls. So if we see all these gases in here, right? And they're ramming into the edges of this container, pushing out against the edges of the container. Now remember, push or pull is a force, and a force distributed over an area is a pressure. So we have all these atoms, molecules, pushing against the outside, creating a force on the outside of the container, and that force is distributed around the whole contact area of the inside of that container, and so it has a pressure. The pressure of that gas is basically an average measure of how much force it's pushing against the outside of that container. If we increase the temperature, when we talk about temperature, we're talking about the speed of the molecules. So they start to speed up and they start hitting the sides of the container with a greater force. So as we speed up the atoms inside, the temperature rises and they hit the sides of the container with greater force. This increases the pressure. So the pressure of a gas and its temperature are directly proportional. When the temperature goes up, the pressure goes up. This is the basic idea of an explosion, right? If we put these two together, we get an explosion. The temperature increases, so the pressure increases. The force is greater. Materials, when they try to release that pressure, they don't get colder. They can't get colder. They're getting hot because either something's heating it, or in an explosion, there's usually a reaction that's creating heat, speeding up the molecules, increasing the pressure. And so the way to lower that pressure, to release that pressure, is usually to create a bigger volume, to release the gas into a greater volume. So the pressure finds the weakest places, like in a house, the windows, and blows those out. It creates so much force on that area that it punctures or compromises the structural stability of that material so that it cracks and breaks, and then the gas escapes into the greater volume, lowering the pressure. So this is basically the idea of explosions, with the sense of gas as being a pressurized material, a compressible material that will change volume depending on the pressure and will change pressure depending on the temperature. So these are all interrelated concepts. Usually an explosion creates so much energy that it excites the molecules to great pressure, and that pressure usually is only contained or released through the gas expanding into a greater volume.